Hello everyone, I am Saptarshi Mukherjee. Welcome to this video. This playlist is about Codeforces round 922, Div 2. And this particular video is about the first problem, problem A, brick wall problem of that contest. Before I start on the problem, I would like to mention something which I always emphasize, that no question is easy or tough. It's only about whether you know it the right way, whether you know the right way of solving it, whether you know the right techniques, and you are clear, you have the clarity about the question and the steps. So anyway, let's get started. So this is the question in front of you. A brick is a strip of size 1 cross k, and you have a brick wall of size n cross m. So this wall you have to create using the bricks of size 1 cross k. This is a single brick, 1 cross k. You have to fill n cross m, and this k can vary. There can be bricks with different values of k in the same brick wall. K has to be greater than or equal to 2. And then it says that, hey, the wall stability is the difference between the number of horizontal bricks and number of vertical bricks, such that if we use 0 horizontal and 2 vertical, then it will be minus 2. So horizontal minus vertical. And we have to find the maximum possible stability. So what is the maximum stability by obeying these conditions? So the only brick that you can use is 1 cross k. You can't use a brick of any other dimension. K can be anything which is greater than or equal to 2. So okay, let's see how it can be solved. So first of all, let's imagine this is somewhat your brick wall. This looks like a square. Imagine that there are n rows and m columns. This is basically the kind of situation, and you are given, or you are allowed to use things like this: 1 cross k. 1 cross k can be 1 cross 2, it can be 1 cross 3, and so on. You can use all these bricks, they are all allowed. You can use 1 cross 4 and so on. It has to be, the breadth has to be an integer, or we can say the length. The length of this has to be an integer. Anyway, now focusing on this, the requirement is that our brick can stay like this, or our brick can stay like this. This is given. Now, what do we have to maximize? We have to maximize this. The horizontal number of bricks, the number of horizontal bricks minus the number of vertical bricks. Yeah. This is what we have to maximize. Now, if we have to maximize something like this, there are two ways. So if this guy increases, then the overall thing increases. If this guy decreases, then the overall thing increases. Which means my attention should be so that the horizontal one increases, that is more, the vertical one is less. Now, less means I can say, hey, I'll not use the vertical ones because that is in the negative side. I want to maximize the entire thing. I'll not use. There is only one thing I need to clarify for that. That's a very good idea. But there is one thing I need to clarify that. What is that? If I use vertical bricks, will I get an advantage somewhere? If I use vertical bricks, will somewhere horizontal bricks also get increased? If I look over here, let's say I use a vertical brick over here. First of all, it is occupying the space. It is occupying some space, which my horizontal bricks cannot use. So definitely that argument is not satisfied. If I use vertical bricks, I'm occupying the space which otherwise my horizontal bricks could have used. So first point is vertical bricks, there is no point of using it. There is another question. Sometimes in the question, there are some constraints due to which you have to take some vertical bricks. You don't have any choice. Over here, without vertical bricks, can I finish the thing? Without vertical bricks, can I finish it? I'll go back to the question. The question says n and m both are greater than or equal to 2. This is where constraints are important. So n and m both are greater than or equal to 2. If I use only horizontal bricks, what is the scenario now? If I use only horizontal bricks, if possible, then I can say horizontal bricks are of breadth 1. So each row will have some horizontal bricks. The next row will have some different horizontal bricks and so on. There will be no horizontal brick which will occupy more than a row, which will overlap, will share a couple of rows, etc. That will not happen. So now my entire attention is, hey, how does one row get filled? Same thing I can do for another row. Or basically I can deal with rows independently. That's where the art of problem solving comes in. That hey, how can I make the problem simpler? I have so many rows, so many columns, but then I say, okay, best is if I don't use vertical, then I use only horizontal. Horizontal means it has basically got to do with this unit size, which means I can dedicate one row to some bricks which will not interfere in another row. Then for another row, I will again start working with some other set of bricks. Then another row, I'll again start working and so on. That's it. Which means that now my rows become independent. So there are two things we have derived by now. One is that vertical blocks are not needed, and the second point is that every row can be handled independently. Every row can be handled independently. Gets occupied independently. Independently means the brick in one row does not have anything to do with another row, which means if few things are independent, I want to maximize an entire thing and some parts are independent, what do? This is a very common strategy. We maximize each part. That is a strategy used in every tough, every easy problems of maximization, minimization, whatever. So I'll focus, hey, every row should be the best. Every row is independent, fine. Make every row the best. Now, how will a single row give me the maximum value? Very clear. I have to use the maximum number of horizontal bricks in a row. So over here, let's say m is equal to something. Let's say it is 7. What is the maximum I can use? I can use a single brick which is 1 into 7. Is that the best? No. 1 into 7 means only one brick. I can rather say, hey, 1 into 3 and 1 into 4. At least I have two bricks. I can share, hey, this is 1 into 3 and this is 1 into 4. So at least I have two bricks. So I want more number of bricks. Nobody has really asked me what should be the length of the bricks. So yeah, that brings me to the point, okay, if increases in length gives me lesser bricks, let me try with reduced length. Smaller length means if a brick is small, then I have many bricks that I can put into there. So okay, I can put 1 into 2. That is the minimum length. So basically, a brick, the k has to be greater than equal to 2. K cannot be less than 2. So I'll take, okay, 1 into 2 is the smallest one possible. This is the smallest brick possible. I'll put it here, 1 into 2. I'll put it here, 1 into 2. Both the dimensions are 1 into 2. Over here, the dimension is 3. If I put a single 1 into 2 over here, that leaves a 1 into 1, which is a headache for me. 1 into 1, this 1 into 1 cannot be filled by a horizontal brick. Vertical bricks can fill. Why should I go into vertical bricks? Vertical bricks will never help me get additional horizontal bricks. So I have thrown vertical bricks out of the picture. So the best thing that I can do now is, okay, let's take it together. Let this be one horizontal brick, because no other horizontal brick can really do anything here. So this becomes my third horizontal brick. So what did I do? I basically said, hey, 1 into 2 is the best thing. 1 into 2 bricks you can keep on placing. And then at the end, if an odd number is left, for example, if 3 is left, 3 means now you cannot take out 2 from there and leave 1. So 3 is the point where you can say, okay, now I'll give one dedicated brick over there. If m is an even number, what do? If m is an even number, you can keep 1 into 2 bricks all over. So if m would have been 8, then it basically looks like this, 1 into 8, and you can divide it into 1, 2, 3, 4, 2, 2, 2, 2. In this way you can basically divide it. That's it. So it's very clear that in this case, every row gives you m by 2 blocks. That is the best you can get. What do you get in this case? It's the floor of m by 2. So the last one unit is, 1 by 2 is zero point 0.5. That zero point 0.5 doesn't give you any extra brick. So basically, you have to rest with the floor of m by 2. And yes, in our programming languages, C++, Java, most of the popular ones, the integer division defaults to the floor. So yes, we can generalize that our final solution is the maximum in every row. Every row is basically m by 2. This is the maximum in every row. Integer division, which will do the floating. And then the overall maximum, the overall answer is, after you maximize all the rows, every row is m by 2. So n rows gives you a total of m by 2 into n. Be very careful, don't multiply n and m before. It might happen that an even n multiplied by an odd m may make the number even, and then when you divide by 2 later, you may get a slightly bigger number. So m by 2 is what you get in every row. Get that and then multiply by n. Otherwise, you may get a wrong answer. For example, over here, let's say if n is equal to 6. So the actual answer is, in each row, you are basically getting 3 bricks. So 3 into 6, the answer should be 18. But if you do n into m by 2, something like this, n into m by 2, so you get something like 6 into 7 by 2, which is 20. This is wrong. So basically, this is wrong. This is not equal to n into m by 2. It's a known fact, just it's about being careful about it. It makes a difference because floating happens, and floating will make differences when multipliers are applied. Yeah. That's it. That's about the first video. If you have any doubts, let me know. Feel free to post your comments on different channels. I've pasted my Codeforces and LinkedIn links also in the description. Please take a, if you have any questions, you can ask on any of those platforms or in the comment section. Do like, share, subscribe if you haven't done yet, and share with people for whom you feel this will be impactful. The insights, the way the problems are solved, should be impactful for a lot many folks. Please do share with them, and see you all in the next videos. Thank you.